Hey guys, we are working on the last part of this unit, which is all about solving for x. And we are going to do some multiplying. So kind of how do we know what we are going to multiply by? So we're going to work through a problem together, and I will keep some kind of recorded notes on the right-hand side as we work through the problem on the left. So the very first thing we are going to do is we are going to let's try that again. We are going to what's called factor the denominator. So we're going to make sure that we can break apart every denominator in terms of its factors. So that'll be step one. When I look at this example on the left, I look at my denominators, and what I see is x minus 3, which is totally fine. There's nothing I can do with that. I see a 2, which, again, totally fine. Nothing I can do with that. And then I see 2x minus 6. And when I look at that 2x minus 6, I can think of that as 2 times x minus 3. It has a GCF. Both parts are being multiplied by 2. Okay. Once we factor our denominators, then we are going to build, or I think I call it in the notes, identify an LCD, which stands for lowest common or least common denominator. And the whole point of this LCD is we have to represent each denominator in our problem in this LCD. Okay, so let's start building. First of all, the first denominator I see is x minus 3. So I got to make sure in my LCD I represent x minus 3. So now that denominator is taken care of. Then the next denominator I see is the 2. So I'm going to put the 2 there. The only reason I put it in the front is because that's traditionally how we write it. It doesn't mean that there's any specific reason for it. The final denominator is 2 and x minus 3, but fortunately that is all accounted for in what I have already written, right? The rule is we got to include all the denominators, but we don't want to double up. Okay? And since the 2 is already in there and the x minus 3 is already in there, we are good to go. Okay? The whole point of finding this least common denominator is we are going to do some work with it. We are going to multiply each fraction by the LCD. And our goal is to cancel anything that we can get to cancel. So this LCD that we took the time to build, I'm going to multiply the first fraction by it. I'm going to multiply the second fraction by it. I'm going to multiply the third fraction by it. And then I'm going to say what can cancel. So in the first one, there's an x minus 3 in the bottom and an x minus 3 in the multiplying, and those will cancel each other out. In the second one, there's a 2 in the bottom and a 2 in the multiplying. Those will cancel out. And in the third one, there's an entire set of 2x minus 3 in the bottom and and that's basically everything we're multiplying by. So we are looking to cancel when we can. The whole reason for canceling is it just makes our equation simpler and easier to work with. So let's look at what we have now. In the first one, we have 2 and x that are multiplying. In the next one, we have the 2's cancel, and so x is multiplying with x minus 3. And then the third one, everything canceled, and so we've got 6x. Okay? So now that we've done that, we are going to simplify. Whoops, let me try that again. We are going to simplify and solve the equation that we just made. Complete with green random stuff. Let's get that out of there. Okay, so that equation that we just made, our goal is to get that simplified and solvable. And so the first thing we have to do is distribute. So I'm going to take that x and I'm going to multiply it by the other x and get x squared. And then I'm going to take x and multiply it with 3 and get 3x and make 6x. So now it's simplified, and we're about to solve it. And when I say solve, I want to know what x equals. So there's some key pieces to how we're going to do that. The first is we are going to collect like terms, 2x and minus 3x. And then we are also going to bring the 6x over from the other side. We'll roll with it. If there's an x squared anywhere in your problem, you need to clear out one side and make one side of your equal sign, needs to equal 0. Okay? So as we clear stuff out, I've got x squared, that's just chilling. And then I've got a minus 3x and a minus 6x, which is a minus 9x. But then I'm putting 2x's back, so I'm at minus 7x. And then we're going to factor this. This one factors kind of funny, not using the x method like we've been doing for most of this chapter. It just factors out an x, which means our final solutions are x equals 0 or x equals 7, because x lies, and so that minus 7 became a plus. So that's how we're getting our solutions. Now there's a weird wrinkle at the end, and that weird wrinkle says that if any answer that you get is an excluded value, then we have to throw that answer out. So it comes back to looking at your LCD. Okay, and the LCD in this problem was 2 and x minus 3. And according to that, x could not be 3 because that would be excluded, because that would be a problem in the denominators. Since x equals 0 was not an excluded value and x equals 7 was not an excluded value, both of our answers here are good. So fortunately, we didn't run into that issue. If you do, kind of just be checking for it and be mindful of it, but I think you're going to do great. Be in touch if you need anything.